Hey there! I'm super excited to share with you some insights on summing numbers in Python. It's something we come across a lot, especially when I start tinkering with Python myself, so let's dive in and explore it together. So, at some point in a programming journey, you'll encounter the need to find the sum of a list of numbers. At first glance, this might seem pretty straightforward, a common enough programming task, right? But as it turns out, there's a whole world of techniques and tips to discuss. Let's start with something everyone learns in the beginning, using a simple for loop and an accumulator. Suppose we want to sum up all the integers from 1 to 100, this is how we might approach it. Python numbers is equal to list, total_sum is equal to 0 for number in numbers, total_sum plus is equal to number. Pretty neat, right? But hold on a second. Ever noticed that when summing up those numbers, it just keeps getting slower as the range grows? That's O-time complexity for ya, no surprises there. Every time we add a number to our total, we are walking through an iteration of the loop. Now, that's pretty efficient for a beginner course, but if you are playing with optimization and you stumbled upon this scenario, you'd want to think about more sophisticated approaches, perhaps even beyond Python itself. Let's jump straight into some Python code. Showcasing this technique, Python n is equal to 100 expected_sum is equal to int2. With this code, we've eliminated the need for any loops, but it remains easy to understand even for those just starting to explore languages beyond basic loops. You can still add all numbers using the formula and sum them up if that's required, but often it's about knowing when a loop is the best or even necessary choice. Now, shifting gears, let's talk about libraries and built-in functions. Python comes with a built-in function known as sum. It's a straightforward way to sum up numbers in a list and often brings in some speed advantages, especially for large lists or when summing frequently. Here we have the same sum but utilizing Python's built-in capabilities. Python numbers is equal to list, total_sum is equal to sum. You see, here we are not handcrafting the logic for summing up items, but relying on Python itself to handle it. It's quite handy, I must say. This method, while not touching on complexity directly, still has a constant time complexity for sum operation, which is pretty good when dealing with real-world datasets or repeated operations. Time complexity is a big deal, especially since we are aiming for efficiency in large-scale projects. You can optimize further using generator expressions inside the sum function. It avoids storing the entire list in memory. Let's see how that looks, and I guarantee you'll see just how powerful Python's built-in tools can get you. Python total_sum is equal to sum. This not only gets the job done without needing a full list, but it's also more memory efficient for larger problems where memory becomes a concern. These are more advanced topics, but as an IT freshie, you are never too small to tackle bigger problems, right? Now, if we start dealing with more complex scenarios, like summing within nested lists or incorporating conditions, we start to see the need for more robust solutions or libraries like NumPy for array operations, which come with their optimization techniques to handle such tasks effectively. These approaches often cater to not just summing, but performing array-wise operations across massive datasets. Alright, we are on a roll here, so let's not stop at summing up. Think about how you'll handle input where the data itself might be a mess. Python gives you tools to preprocess that data before summing. Remember, clean data always makes for a cleaner task at hand. In reality, oftentimes, you might be dealing with a mix of numbers and data anomalies. Python's standard library filter, and map come in handy to clean and prepare your data for processing before the summing kicks in. Combining these with list comprehensions can handle data of various shapes and sizes elegantly and efficiently. It's like prepping your list of numbers, cleaning up pebbles, and then summing up the marbles, everything shining and ready for use. Python cleaned_data is equal to filter, mixed_data, total_sum is equal to sum. Here, we are filtering out non-integers which might throw wrenches in our summing journey. It's like refining raw ore in a mine to get to the gold. Python makes you appreciate every tool in the treasure chest it offers. As we continue, let's not forget testing. Python has a unit test module to keep everything running smoothly. Test-driven development puts confidence in code and makes us ponder, is this the best summing approach when we scale up? Python import unit test class test summation methods, definite test_basic_sum, self.as cert expected_sum, definite test_sum with built-in, self.as cert sum. Hash tests for larger sets and more complex cases would come here later if __name__ is equal to __main__banana__. Unitest.ma in tests become our best friend when ensuring we not only sum accurately but elegantly under conditions we may not immediately expect, a shield and sword for our code in maintaining quality. Now, as a final note before I wrap up, always remember, learning new techniques is a process. There's beauty in simplicity when we are just getting started, and complexity emerges beautifully as we explore deeper. Python, with its rich tapestry, lends itself to endless discovery, from simple to complex summing and beyond. I've just scratched the surface on summing numbers in Python, but you've now got your tool belt equipped with fundamental loops and the wonders of built-in functions, math formulas, and cleanliness in handling data. As we venture out of these initial discussions, we'll continue to explore libraries like NumPy and data analysis techniques for handling extensive datasets. Whenever you are ready, remember to keep an open mind as we dive deeper into more complex scenarios. I encourage you to look into optimization techniques for summation of very large datasets, understanding the trade-offs involved, and when best to apply different strategies. Always look for the best solution for the problem at hand, which sometimes means stepping back and analyzing it from the outside in. By keeping on the path of learning and improving, you are making incredible strides in your IT journey. Stay curious, keep experimenting, optimizing, and of course, have fun with coding. Remember, summing numbers in Python is not just about adding digits, it's a gateway into a realm rich with knowledge and exploration. Make sure to visit neeraj.qzz.io and subscribe to TechLab for more wisdom to fuel your coding endeavors. Until next time, happy coding. To stay updated on all the coding wisdom out there, don't forget to follow along on social media for daily dose of tech knowledge. And just like that, we've wrapped up this enlightening discussion on summing numbers in Python. As you step back into the digital world, carrying with you new insights, always remember that the journey of learning and discovery in coding doesn't end here. Every line of code sums up to a greater understanding and proficiency. Happy summing and until next time.